Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of numerical integration. In this particular episode, we are so much interested in the trapezoidal rule. In subsequent, sorry, in previous episode, we were looking at the Riemann sums, the midpoint rule, and all of that. But in this particular episode, we are going to focus more on the trapezoidal rule and what is it about. So stay with me even as we explore that together. And at this point, if you have not subscribed, please do so. Like my content, comment, help spread this content with your colleagues, with your loved ones. Thank you so much. Let's get going. Now, with the trapezoidal rule, as I mentioned, is a very powerful, method for finding an approximate value of some definite integral. Okay, good. Now, what are we so much interested in? Why are we so much interested in the trapezoidal rule? Trapezoidal rule, what it does is that it tends to kind of take a trapezoid and then you rate it over each sub interval, just like the way we treated we treated the midpoint rule and that of the Riemann sum. We pick a trapezoid, then we draw that in over each sub interval. So in a second, I will explain that so that you will get it, and also the formula, how we are also going to use the formula. We will talk about that. So suppose we have this a definite integral to find an approximate value of that. Okay, how do we use the trapezoidal rule? So as usual, we would need about so in this case, our interval is A to B, right? So what we are going to do is that we are going to subdivide this interval into several intervals. Okay, we're going to have several sub interval out of this particular interval. Okay, then would bear it in mind that we also have to get our weight. Okay, our weight as usual is just going to be b minus a on n. N is the number of subdivisions or number of partitions we want to have. Okay, now what is the formula? How do we use the formula to what is another question? What's the formula for the trapezoidal rule? The trapezoidal rule, the formula is the delta, multiplying. So first we evaluate the function at the first point, which is a, then we divide it by 2, then we kind of also approximate it at the other points as well. I believe we are okay. All right. So so this is the formula that we are going to use to be able to find an approximate value of this particular definite integral. So what I'm going to do is that I'm going to pick an example, then I'll take my time and explain it one thing after the other. Okay, so please stay with me even as we do that together. So suppose we are given this particular problem. So with an example, so this example we're asked to use the trapezoidal rule to find an approximate value of using 6. In other words, n equal to 6. Okay, equal sized sub intervals. Now, how do we use the trapezoidal rule? Now, the first thing to do, we need to, write down our formula. Okay, what is the formula? So let's write it down. So our formula is, since n is 6, we are going to have t6 equal to delta 6 multiplying f evaluated at what? At a divided by 2 plus f of x1 plus f of what? X2, f of x3 plus f of x4 to 1, 2, 3, 4, 5. Then finally we get to, so we have 1, 2, 3, 4, 5, 6. Okay, so we have this as 6. All right, so this is what we are going to have. Now, what we are going to do, we need to find our f of, remember our a is the lower limit of this definite integral, and then the b is the upper limit. Now, since we know, now the next thing we need to do is to find our delta. Our delta is, we know, is what? B minus a on n, right? What is our b? Our b from this is 3, and our a is 0, and our n is 6, but from the question it was given us that. So it means we're going to have 0.5. Okay. So now we need to find our f of a. Remember, our f of a, our a is 0. Okay. The a is the lower limit of the definite integral, which is 0. Okay. So we need to find f of 0, which is what? So f of 0, it means that, but remember our integrand, let me write down. Remember our integrand, per the question, our integrand, which is f of x equal to root of e to the power x plus 1. Is that okay? Then our f of 0 will be what? Will be e to the power 0 plus 1. And that should give us what? 1.4142. Is that okay? Then we also have to find our f of x1. So our f of x1, if our f of x1 will be would have a step size of what? Since already we have a weight of 0.5, it means that the next value will just be 0.5, okay? So our sub intervals will just be from 0, we have 0, 0.5, we have 1, 1.5, you have 2, 2.5, and up to 3. Okay, so these are the values that we're going to use, okay? If you have a weight of 0.5, it means that these are within the interval from 0 to 5, we can partition it into this form, okay? So it means that our f of 0.5, we just plug it into the integrand, and that should give us what? That should give us 1.6275. Then we also have to, now we have found 0, 0, and then we need to find f of 1. So f of 1 will just be, will give us what? Will be a 1.9283. And then f of then we, at this point we are moving to 0.5, okay? 1.5. So f of 1.5 should give us e to the power 1.5 plus 1. And that should give us f of 2, f of 2 should give us 2.8964, and f of 2.5, so we plug that into that, and that should give us then f of 3 will be equal to root of point. Now, at this point, what that we need to do is that now, since we have the formula, so per the formula, we are going to have, remember our this is our formula, okay? So we have our width to be to be 0.5. Okay, so we're gonna have 0.5 multiplying our f of 0 was 1.4142, then we divided by 2, then plus our f of 0.5, that was 1.6275. Then we have our f of 1 was 1.9283. Our f of 2 was 2.8964. 1.5 was 2.3413. F of 2.5 was 3.6308. And then our last point was 4.5919. Then we divide that by 2. And then when we do that, that should give us the 7.714. Okay. So this is what we are going to have. So this is the value that we're going to have, which is also very close to, remember, um in our previous example that we saw that the definite integral problem was we had 7 point when we do it when we kind of find it computation, we are going to have 7.67548. Okay, this is what the exact value we need to have. But what the trapezoidal rule has given us is 7.714, which is just a little above the actual value, which is also not too bad. Okay, and at this point, if you have not subscribed, please do so. Like my content, turn on your notification button so that anytime I release new content, you'll be the first to receive that. And also, please help spread this content, share it with your colleagues, with your loved ones, and let us help demystify the myth around mathematics. Thank you.